Sawtooth pattern of Macaulay duration. Now what do we mean by this? Let's understand with an example. Let's say we take the example of this bond only. The bond with a Macaulay duration of 2.2353 and a maturity of 3 years. So let us write the numbers 0, 1, 2, 3. Now this time we think in a reverse sense, my friends. Reverse sense means t is 0 here, t is 1 here, t is 2 here and t is 3, that is the maturity comes here. Okay. If t is 0 here, then this 3 becomes time to maturity of the bond, right? So let's say we draw a horizontal axis which depicts the time to maturity and a vertical axis which depicts the Macaulay duration, right? Now this bond has a Macaulay duration of 2.235, right? Let's say this is 0, this is 1, this is 2 and 2.2353 somewhere here. So this is 2.23 approximately. So we start from here, right? So we start from this point. If it were only about the flat price and there was no full price or accrued interest involved, then this duration would be just a straight line joining 0 to this point, like this. But there is a problem, friends. At t is equal to 1 and at t is equal to 2, there are cash flows due. So there is a question of accrued interest if you are looking at any interim period, right? So the Macaulay duration moves like this. Say this is the period 1. Here it will be continuously pushed down by the accrued interest. The accrued interest keeps on increasing because accrued interest, as we know, my friends, is t by t into the periodic payment. So t is, this small t is the time elapsed from the last period and this one is the total time between two periods, right? So as this proceeds towards, as the time to maturity proceeds, this t keeps on increasing, this t keeps on increasing, and as this keeps on increasing, the AI, that is the accrued interest, also keeps on increasing. Therefore, there is a downward pressure in the Macaulay duration continuously till the cash flow period is due. The moment the cash flow is paid, for a single instance, the Macaulay duration jumps back and merges with the smooth line. But then again, the next period's interest is accruing, right? So there is again downward pressure here. Till t is equal to 2. At t is equal to 2, again when the interest is paid, it merges with the smooth line. And for the last payment, because there is only one payment, there is no difference between the smoothened line and the Macaulay duration. There is no question of dividing the proportion between accrued interest and the full price. So this is why this sawtooth pattern is seen in the Macaulay duration.